All right, so yesterday we looked at 12.4. Okay, 12.4 was on solving systems using elimination. What was the method we did right before elimination? That was substitution. And what was the method before that? Graphing. Good. Okay, so we're going to continue on today with the same method, okay, using elimination.
And again, guys, that example that Mr. Hager is going to scroll down to in a second, that's not the example that needs to go on your sheet. All right, you do not, that we're showing you right now, you don't need to write that down. When I get up on the board, just like yesterday, that's when we're going to start writing stuff down. All we're doing is listening right now. That's it.
So let's take a look at this, similar to the kind of problem we would have had yesterday. We're looking for three things. Two things the same, one thing opposite. Go ahead, Savon.
Same variable.
Same variable.
Same number.
Same number.
And opposite, like operation.
Yep, opposite signs, positive, negative. Okay. If we look at this equation, we've got the same variable, we've got the same number. Do we have opposite operations?
No.
No. They're both positive. Okay. So let's see what would happen if we add them up. Usually we add them up and one of them disappears. Okay, let's see what happens. What's negative x plus 4x? 3x. What's y plus y? Which one came out to 0? Neither one of them. Okay, so doing exactly the same thing we did yesterday won't work. Okay? We just have to change it slightly to make it work. So adding the equations together, Savon just showed us, didn't eliminate anything. Okay. Sometimes what we need to do is take one of the equations, today it's just going to be one of them, and we have to multiply everything in that equation by a constant. Okay. A constant is just a number. It can be any number you want. Don't use decimals and fractions. Okay. We're going to pick numbers that are easy to work with. And you've got to multiply everything by a number before you can do the method we did yesterday. This is still elimination. It's also called the addition method. And your book also refers to it as a linear combination. All those three things mean the same thing. Three different words for doing the same thing. Basically, we're going to add things up, and we want them to cancel out. Okay, when you multiply an equation by a number, okay, that's a constant, just a number. You have to do it everywhere. Right? You have to do it in every single term. So if we go back up, look at both of these equations. Let me show you, I'll do it and just tell you what would happen. Let's multiply everything in this top equation by the number -1.
Guys, when Mr. Hager, right, when he multiplies, how is he going to multiply? What would he use? Obviously, he's going to use multiplication, but what's the property he would use to be able to multiply to everything in that problem? Huh? Division? Not division. We've done it a bunch of times. We did it a lot last week when we did substitution. Deals with parentheses. Right? Distributive property, right? When we've done the distributive property so far this year, right? We've had, right? I'll just do the box. This box is like the term on the outside. Then we had the stuff on the inside, right? Typically, how many times, Isaiah? Typically, how many times did we distribute that number to the numbers inside? How many times did we do it? Okay, as many times as there are terms inside. Typically, though, how many terms are there on the inside? Usually, in most problems we've done. 2, right? We've only had to distribute it twice. Mr. Hager is going to show you, with these, we've got to do something a little bit different. You'll see.
So right now, I'm just kind of showing you the idea. Mr. Roy is going to go through a full example in a minute. So I do -1 times x. You make it positive x. I'm going to do -1 times y. Watch what just happened. Now I'm going to do -1 times -3. Do you see the same variable, same number, and opposite signs now? Yeah, right here. If you add these y's together, they would cancel out. Right? And now you could solve it. Right? So that's the only difference between what we did yesterday and today.
So guys, see what I was showing you before, right? We multiplied by, when we did regular distribution, we did one term by the 2 on the inside. This time, we gotta do all 3, even the number that comes after the equal sign. Right? A lot of times when kids do this, guys, I see them forget to multiply or distribute to the number that's after the equal sign. All right? You've got to distribute to all 3 things. All right? The 2 terms before the equal sign, which are going to probably, which should be letters, and then the 1 number after the equal sign. Okay?
Any question on that idea?
And again, guys, there's a template for this, just like we had yesterday, but like I told you yesterday, we're just adding a step. And we're going to explain that in a second.
And you might look at it and be like, well, why did you multiply by -1? Couldn't you have multiplied the bottom by -1? That would have worked as well. Right? There's multiple ways to do this.
We could have multiplied the top by 4. That would have gave us -4x and 4 on the bottom. There's a lot of different ways that you can use elimination, and a lot of different numbers you could use to multiply. All right, we're going to try to give you guys some hints on the easiest numbers to choose, or the best equations to choose when you do that. Okay?
So as we go through it, you guys might look at how Mr. Roy does it or how I do it and be like, well, I would have done it differently. That's fine. There are multiple ways to do it.
Yeah, I think like Kayla said yesterday, oh, Mr. Hager, Mr. Roy, couldn't I just flip that around and do it that way? That's fine. All right? That's perfectly fine. So, all right, so just like yesterday, Mr. Hager, I had that. All right, so just like yesterday, so now we're starting to get to where it says linear combination, distribute to 1 equation only. Okay, we're getting to that. We're not quite on it yet. We get a little background info, then we're going to get to it, okay? So we're going to use the same template to solve, but just a little bit more information in the steps. Still 3 boxes, but what happens in those boxes might be a little bit different as to what we did yesterday, but not too much, okay? So, first thing, just like yesterday. So now we're going to write down the example. So just like Mr. Hager showed us, here's our example. All right, this is example 1A for today. All right, equation number 1, -x plus y equals -3. Bottom equation, 4x plus y equals 2. All right, so we got, that's the one on the top, that's the one on the bottom. Now, yesterday, on the boxes from yesterday, we didn't have this. Multiply top or bottom to eliminate. That's the first question you're going to ask yourself, right? Like it says up here, so on the lines that are above that first box, we're going to multiply one of the equations by a number to eliminate. All right, we're going to multiply one. Today, we're only going to multiply in one of the equations. Sometimes it might be the top, sometimes it might be the bottom, depending on what you have, what you're given. All right, you have to make that decision. Like Mr. Hager said at the beginning, it could be different. Sometimes it might be like what, say, Vaughn does on one problem could be totally different from what Travis does on one problem. All right? It's whatever works for you. All right? So we got that. Same thing all week long. Is it lined up? Who can tell me? What does that mean, is it lined up? Yep, match up the letters, right? Make sure the letters are over each other. Which, in this problem, do we have that? Or we don't have that? Yeah, we got them both, right? Remember, what's the goal? Where do we want the letters? On what side of the equal sign? Letters on the left, L on the L, letters on the left. What about on the right-hand side? Just the plain numbers. All right, with no variables attached. All right, so we got that. Now, the first thing we got to ask ourselves is, which equation would it be good to multiply by? Should we multiply in the top equation, or should we multiply in the bottom equation? We want to multiply in the top? Either one works.
No, do top.
We want to do the top? All right. We're going to, so Tell me, everyone's got to vote. Who wants the top? Tell me.
Oh my.
Who wants the bottom? All right, top it is. So, circle, we're going to multiply the top. Now, when we multiply the top, all right, what variable do you want to eliminate? You want to eliminate the x or the y? Why? Because it's already by itself. It's easier. When you have two variables by themselves, when they have the same sign, all right, eliminate that. All right, it's going to make your life a lot easier. All right, so in this little line where it says to eliminate, you guys said we want to eliminate y. If you need to, like we did yesterday, we're going to get to it a little bit later, all right? You may get a situation where you have to rearrange stuff. You have this space to do that if you need to. You have space below it to rearrange and get everything lined up. Okay? So, in the box, all right, we said we're worried about the top equation right now. In that box, we're going to put the number that we're multiplying everything by to get that y to be same number, same letter, different sign. So what am I going to multiply by to get that y to be what we want it to be?
-1.
We're going to multiply by -1. So in this box, I'm going to put -1. All right? We have two boxes here because it could be different. Like I said, you could be multiplying in the bottom equation sometimes. It all depends on what you're given. In this case, we don't need this. Put an x through it. We're not multiplying the bottom by anything. Okay? Now this is when we get to the part where it's a little bit different from yesterday. All right? So, we're going to eliminate one variable, just like we did yesterday, and solve for the other. We're going to eliminate one variable and solve for the other. But yet, I'll let you guys write that down first. I don't want to confuse you. Everybody good? Super, okay. Because I want to explain how that middle box is going to be a little bit different than yesterday. And I want people to be like, Mr. Roy, like, you're trying to write, you're trying to listen at the same time, like, honestly, not really quite sure what he's talking about. That's why I want to give you guys time to write down that step. All right? Give you about 15 more seconds. Okay. So, when I rewrite my equation here, remember yesterday we had the black line over here and we did our elimination and then we rewrote to solve for the variable here? We're going to do both those things in this step, in this middle box. We're going to eliminate and then we're going to solve for the variable. Remember we had it in 2 steps yesterday? We had it happening over here, then we wrote what we had left to solve for that variable. We're just doing it a little bit differently today. All right, we're going to eliminate and then do the work down in this space to get what that first variable is going to be. All right, so when I multiply this -1 times these 3 things, I'm going to write my result right here, what I get. So I'm doing -1 times what first?
Negative x.
-x. So what would I get if I did that, guys?
Positive x.
Just the x. You can put 1x if you don't want. If you want to, you don't need to. X. Again, I'm multiplying. I'm doing this right now. Multiplying this by everything. Remember, sign to the left goes with it. Sign to the left goes with that number. It belongs with it. They're together. All right? So I did -1 times -x gave me x. All right? Dominic, what am I multiplying next?
The y.
Huh?
The y.
To the y, right? So tell me what the problem is. -1 times
Y.
y, which will give me?
Or negative y.
Okay, good. -y. That's really important. That's what we want to eliminate. Last thing I want to do is what? Tyler, what's the last thing I want to multiply? I did this. I did that. What's left?
3.
-1 times -3 will give you. What will it give you?
Positive 3.
Just the 3, right? Equal sign 3. That's the one thing that's a little bit different when we're doing this, right? Because when we've done it before, we just did it by 2 terms. Today, we're doing it by 3. For the rest of the week, we're going to multiply by the 3 terms. The number after the equal sign needs to be multiplied too. That's a little bit different than stuff we've done before. So bang, good. Nothing happens down here. I got my x in the box. I'm not multiplying by anything. It stays, right? I'm just rewriting that equation. Plus y equals 2. What's this arrow mean? A little dotted arrow going up and down? Huh? Why did I put that there?
To line them up.
So they're lined up. We knew that. Good, Justin.
Multiply up and down.
No, I like the way you're saying to do the math, but you said the wrong operation.
Divide up.
No.
Add.
Add, right? Remember, addition, but Justin, perfect in terms of lining them up and doing it that way. That's the way we want to do our math, going up and down, right? We're going to add them together. What do I get when I do this, guys?
5x equals
5x. We said over here, we're eliminating y. It's gone. I don't have to write 0, none of that crap. Don't do have to do any extra work. And then, like KJ said, 3 plus 2, 5. Emma, last step.
7. Divide by 5.
Divide by 5. Just like we did yesterday. Whatever's left goes here. This cancels. X equals what? 1. Again, just adding one more step. All right? Wherever we're multiplying by, we're writing that down. We're doing our elimination. Then we're doing the work to get that first variable. Yesterday, we just had, this wasn't here, this piece. We did it over here. We're just doing it in one box today. That's all. That's the big change. That's the only thing we're doing that's different in terms of as far as the way the template's set up. Right, last box. Just like we did yesterday. Plug that variable that we just got into an original equation and solve. Again, this is where you have the freedom. It's up to you. You can use the top one or the bottom one. All right? You can use the top one or the bottom one. It's entirely up to you. Which would be a better one to use? The top one or the bottom one? What do people think? So the bottom one, all right? The top one is here, all right, and I got bottom here. Me personally, I would use the top one. How come?
Lower numbers.
Lower number too, right? It's just got that negative sign, right? Man, I could have put it in down here, right? What's this mean for the x next to it? What math operation? Times, right? Good, Tyler. This means multiplication, right? Again, I can save myself a step if I want. So when you have to plug it in, right, back into the original equation, if that variable you solve for, whether it be x, y, a, b, if it's already by itself over there, plug it in for that one. Save yourself some work. All right? Next, so in this case, it's not by itself. It's got a negative attached. That's your next best option. After that, then you got to decide, okay, like I think it was Isaiah that said it, if there's numbers attached to that variable in both, multiply by the smaller one.
But you can't use the problems that you times by 1.
Huh?
Can you use the problems of times by 1?
Use this?
Yeah.
No, you're going to use the original. All right? So I'm going back here. You guys did use the first one, right? So negative what? I'm using the top equation. Negative what, guys? Negative 1. What's left after that? Plus y. Keep going. Equals negative 3. All I did, took this, put it in the place of x. The negative sign stays. It doesn't just disappear. It's part of it. The only thing that's changing is the x. There's a number taking the place of the x. All right? So, now,
Okay.
Ryan, what are we going to do now? If you answer this question, I'll let you go to the bathroom. Careful.
You know what to do.
How do you get y by itself, Ryan? Not divide. How do I get that by itself with nothing else with it? Add what? Good job. Fill your agenda, you can go. Add 1 to both sides, right? When I do that, so plus 1, negative 3 plus 1, what's my answer? Negative 2. And again, there's my final answer. Now, for that one, we multiplied by negative 1. Every problem you do today, you're only going to be multiplying, you're only going to be changing one of the equations. Like I said, it could be the top one, it could be the bottom one. We don't know. All right, depends on what we're given to set it up. All right, to get what we want. All right, so we're only going to be multiplying by 1 today. By 1, we're only going to be changing one of those equations. The number we multiply by could be different. It might be -1 sometimes. It could be 2. It could be 3. It could be 5. All right, but this is the same. Like I said, the only thing that really changes here is we're eliminating in this box and also solving for one of the variables in that middle box. That's the only real change. Okay?
Wait, can you go back?
Yep. Question?
Just
Scott? Mr. Ray, they got 1B?
No.
Okay.
Guys, just like yesterday, again, all the examples are on the sheet.
Okay, so while Mr. Roy is passing that out, I want you to look at the board and see if there's something you could multiply. Pick the top or bottom equation. And try to think of a number in your head that you can multiply it by. I think, well, just think about it for a second.
Where did we put this one on the back?
No,
Oh, he's giving out a worksheet.
just like yesterday. All right, all the examples from here on out are on the example sheet that I'm giving you right now. And again, you can just use the little, the one with all the different methods on it. It's for reference. And some people that I worked with today in learning support, while they were doing their homework, they had that sheet out. All right, no tricks on Friday. No tricks on Friday. All right, you're going to be able to use that sheet, and you'll also be able to use the study guide sheet that we give you, like we always do on Thursday with problems set up like ones on the test.
You never have learning support when I need you. You never have learning support when I need you.
All right, so I think there's a clear variable here that you want to get rid of. Which one do you think we're going to try to get rid of? X, okay? If you try to get rid of y, that's going to be hard, okay? The reason, there's nothing I can multiply 3 by to get 5 without using a fraction. Okay? That's going to be difficult. So y is probably not going to be the variable. You guys said x, that's good. Okay, how do we want to do it? Do you want to multiply top or bottom? You really could do either one. It's not going to matter. How many people say top?
I'd say bottom.
Okay, top? All right, let's do the top. Okay, so now the question is, what would you multiply the top by to eliminate?
2. Let's go 2.
Has to be negative.
Yeah, it's got to be negative because we're trying to eliminate x.
But it's negative 1.
Negative 1. Perfect.
Negative 2x.
Calm down, Isaiah.
Okay, so remember your goal is to try to get those 3 criteria Mr. Roy said yesterday. Same variable, same number, opposite signs. Okay. What are we doing to the bottom equation? Nothing. Copy it over right away. Okay, it stays the same. What's the property that Mr. Roy explained we're using with that negative 1 to multiply it to everything? Justin, do you remember that? What's that called when you take a number and multiply it to everything? Begins with a D. Distributive, good. Okay, multiply that negative 1 by all 3. Okay. What's negative 1 times x? Kayla?
Negative 1 times x.
Yeah.
Negative 1x.
Yeah, you get negative 1x. Or just negative x. Dominic, what's negative 1 times negative 3y? Good. Positive what? 3y. Isaiah, on the other side, what's negative 1 times 18?
Negative 18
negative 18. Okay, remember this dotted line? Means you're going to combine your like terms vertically, okay, by adding.
Cancel out your x's.
X's are going to cancel out. Negative x, positive x. What's 3y plus 5y?
8y.
8y. And negative 18 plus 2.
Negative 16.
Negative 16.
Divide by 8.
Isaiah, what do I do next?
You divide 8 and 16.
Divide,
Well, you divide 16 by 8.
divide
and you
each side by,
get -2.
good. Okay, so we get y equals negative 2. Okay, now we have a choice. We can plug it back into the top equation or the bottom equation. In this case, yeah, it doesn't, you want to do the top? Okay, so we're going to fill in the top equation. So it's x minus 3, and what are we filling in for y? Negative 2 equals 18. Next, we've got to do negative 3 times negative 2.
Positive 6.
Negative times negative is positive 6.
And you subtract 6 from each side.
Yeah, we subtract 6 from both sides.
And you get 12.
And 18 minus 6? Go ahead, what is it?
12.
What's it, 12? Okay, very good. Okay, any question on that one? Okay, so that's the main idea. Pick an equation. Okay, this one happened to be negative 1 again. We got to do one that's not negative 1 because I don't want you to think it's negative 1 every time. It's not. Okay, here's one that, yeah, negative 1 won't work this time. Okay, so don't say it out loud, just look at it. Look at it for a minute. And you want to see, is there something I could multiply by that's going to get rid of one of those letters? One letter I think is hard to get rid of because that number is not a multiple of the other. Okay, so before we say it, which equation you think we're going to multiply by? Top or bottom? Which one? Top. Yeah, I would do the top. Okay, we're going to multiply the top.
Cancel with the 6.
What are we going to try to eliminate?
Y.
Yeah, we're going to try to eliminate y. So we've got to multiply the top by something that's going to give us a negative 6y in the top. So it cancels positive 6y in the bottom. Travis, what would I multiply that top equation by?
Negative 1 and 6.
No, negative 1 wouldn't cancel anything out. Our
And it has to be positive.
goal is to eliminate y.
Divided by negative 6. Positive 6.
Positive 6? Anybody else think positive 6? Positive 6? Okay, let's just try it and let's see what happens. Emma, what's 2x times 6? 12x. Spencer, what's negative y times 6? Yep, negative 6y. And lastly, what's 6 times negative 8? How about Marcus?
48.
And it's positive times a negative? Okay. So 6 times negative 8 is negative 48. Isaiah, what am I doing with this bottom equation?
You're just bringing it over.
Yep, we're just bringing it over. Making sure you keep your x's lined up, keep your y's lined up, keep your numbers lined up. What's going to happen now when I add those equations together? What's going to cancel?
6y.
Negative 6y, positive 6y. That's gone.
Well, it's 15x.
Okay, so let's go through it. 12x and 3x. What did you just say, Isaiah?
It's going to be 15x
15x.
equals 60.
Close, just be careful with your sign.
Negative.
Negative 60. Okay, Joe, how do I get this 15 on the other side? Good. Divide by 15. And put our answer. Austin, what's negative 60 divided by 15? Careful, it's a negative divided by positive. Negative 4. Good. Okay. Which equation should we plug negative 4 back into? Top or bottom? How many people think top? Top? Okay, let's fill it in. So Wyatt, what's it going to be? 2 times negative 4 minus y equals negative 8. Okay. William, what's 2 times negative 4? Negative 8. Okay. 2 steps left. Joe, what's my next step? Yeah, good. Plus 8. What's negative 8 plus 8? How about Brian? Careful, it's negative 8 plus 8. So it's like opposites. Negative 8 plus 8. 0. So that cancels out. Negative 8 plus 8, you get 0 on the other side. Okay. What number is in front of y here?
Negative 1.
Negative 1. So how would we move the negative 1 to the other side? Divide by what, Victoria? And 0 divided by anything is always what number? 0. Y equals 0. Okay, so any question on the type where it's already lined up for you? X's are lined up, Y's are lined up, numbers are lined up. Okay. So we're going to look at a type where now you have to line up the like terms in the same column. Okay, they're not lined up yet. So before we even write anything in equation 1 and 2, I don't want to put anything in these boxes till everything is nice and lined up. Okay? Mr. Roy said we got some scrap, we got some room down here. We're going to do some work down here to fix what we need to fix.
So guys, why don't you take 30 seconds? Because this is not, we're not multiplying yet. We're not doing anything like that yet. There was a couple we did. There was one yesterday in the problems we did in class. We had to rearrange. There was one of the homework last night that we had to rearrange. Before we even get to that point.
Yeah, I was going to say, is there any equation here that is already fine? You don't need to mess with it.
Bottom one.
The bottom one. Okay? Fill that in for equation 2 right now.
Yeah.
I don't want you to mess with that one. I want you to make the top one look just like the bottom.
So take 45 seconds. See if you can figure it out. Take 45. Again, we're not doing any distributing yet. We're not identifying what term.
All right, let's take a look. Okay, so Mr. I gave you guys a hint. There's only one thing that needs to move.
So before we even decide what we have to do, which in that top equation, Eli, stay with me. In that top equation, Laura, which thing is out of place?
Negative y.
Remember, what did we say yesterday, right? I said at the beginning of class too, we want letters where? Letters left and numbers right, okay? So if I'm looking at the right-hand side, right, I got a number and a letter, all right? So I definitely gotta get rid of that letter, right? That letter on the right-hand side. What is the number, the sign, and the letter on that right-hand side? Help us out, Shelby. Negative 4x, right? It's out of place. Shelby, to move it, what's Mr. Hager have to do? Do the opposite, which would be what? Plus 4x. when I move it to the other side, Shelby, when I rewrite that, right? How would I write it?
4x minus y.
Exactly. 4x minus y equals 7. Okay? Everything's gonna be lined up now, right? Just like we did before. And hopefully we'll have some time. In the homework last night, there was one on there where it was out of order, but the y and the x were out of order, but they were on the same side of the sign. So we just change them around. We'll go over that. Hopefully we'll have some time. Right? But for this one, if it's on the opposite side, just like we've done with other things, we gotta do the opposite operation, like Shelby said.
All right, so now we got all the x's lined up. We got the y's lined up. Got the numbers on the other side. Okay, so take a second, look at it yourself now and think, all right, you're going to multiply top or bottom. And then what are we going to try to eliminate? Okay, a hint is if you look at the numbers in front of x, is 5 a multiple of 4? No, multiples of 5 are like 5, 10, 15, 20. Multiples of 4 are 4, 8, 12, 16. It's not going to be easy to get rid of the x's. So what are we going to get rid of? We're going to get rid of the y. Are we going to multiply the top or the bottom? Top. Okay, multiply the top. What could we multiply the top by to cancel out the y's? Anybody think they see? Yeah, Brian? What is it? 3, great. That's exactly it, perfect. You're going to multiply that top equation by 3. Bottom equation, put an x in it. Okay, we're not multiplying bottom. Since I didn't change the bottom, what should I do with it? Yeah, keep it the same. 5x plus 3y equals 13. Okay. Multiply that 3 out. Okay, Travis, what's 3 times 4x?
4x is 12x.
Good, 12x. Okay, Dominic, what's 3 times negative y? 3 times negative y. Good. Last part, 3 times 7. How about Shelby? What's 3 times 7? 21. Okay, when we add these together, Victoria, what disappears? The y's. 12 and 5 gives us... Careful, 12 and 5 is how much? Yep. 17. 21 and 13 gives us 34. Looking at that, I thought we were going to get a messy answer at first, but I think we're gonna get a nice answer here. Last step, divide each side by 17. Spencer, what's 34 divided by 17? 2. Comes out nice, comes out to 2. Okay, any question on that? Okay, now what do I do with the 2? Plug it back in. Okay, and I got a few different choices. Okay, I've got a few different choices for where I can plug it back in. I could go back to the originals, or I could go back to one of the ones I rearranged. Okay? I usually go back to the original, and somebody said the top one. I think the top one is a good one to pick. It's not going to be 4 times x. Sam, what am I going to fill in for x? 2. Fill in 2 in place of x. Okay. Don't forget about this negative in front of the y. Okay, a lot of people forget about it and then they get it wrong. 4 times 2. Isaiah, how much is 4 times 2? So we have 7 minus 8. Okay. Justin, what's 7 minus 8?
9. 8.
Try again. 7. If you have $7 and you take away 8,
Oh, duh. Are you stupid?
what do you have left?
7 times 8.
Oh.
Negative 1. All right. So we have negative y equals negative 1. So how do I divide by negative 1? Okay, so Ryan, what's y? Y is what? It's a negative divided by a negative becomes a what? Positive.
Mr. Hager, I know, guys, listen, this might be important to some people, yeah? So guys, when you, maybe I missed a mistake because I wasn't paying attention, you can, if you, like in that case, you had to rearrange, or you can, that's my question, yeah, hang on a second.
Ask him if you
Help me out here, Lou.
use your
Oh,
like
yeah, can you-
multiplied question.
Yeah,
Oh, when you plug x back in, you can plug x into the originals, you can plug it into the new ones, either way.
okay.
Yep,
So you can even plug it into what you multiplied by, right?
sure.
Okay.
Yep, you could. Okay, any other questions on that? All right. Okay, for now, I'm skipping over 2b. Okay, maybe you guys will have to try that on your own.
We'll give you some time at the end to do 2B, okay? That'll be one of our practice.
Okay, so this one is, does everybody have the word problem written down?
Yeah,
They
it's
got it?
already written down.
All right, so like we said yesterday, right? For a large fruit basket, it's just telling us what it is.
So that doesn't matter.
Doesn't matter to us.
Cross it out.
So as we read through this, for a large fruit basket, we're not worried about. I'm going to read the whole thing, and then we'll break it down. 8 grapefruit and 14 apples weigh 15 pounds. For a small basket, 4 grapefruit and 10 apples weigh 9 pounds. Find the weight of a grapefruit and an apple.
The first one's 8G plus 14A.
So what Tyler's saying is he's going to represent the grapefruit as G. He's going to represent the apples as A. So grapefruit, G, apples, A. He's also saying that this weigh, when it says weigh 15 pounds, what's weigh going to translate to? Equals. So weigh means equals, weigh means equals. All right? What does and mean?
Plus.
Plus. Put a plus over that. And I think I had an and down here. Yep. Plus. Plus. So like Tyler was just telling us, I'm going to scroll down a little bit. He said G, oh, I'm sorry. Eight G plus, so I can see it, 8G plus 14A. All right, so that was that first, well actually the second sentence, because the first sentence was just the grapefruit, that's all, I mean the fruit basket, right? We didn't have to worry about that. This is for that first piece of information, from here all the way to here. So 8 grapefruit and 14 apples weigh 15 pounds. All right, 8G plus 14A equals 15 pounds. All I did was go through, like Tyler told me. He wants to represent grapefruit in terms of G. He wants to apples as A. I crossed those words out and changed them with the letter that we want to represent them. That's all I did. I looked for key words and what they meant. In this problem, and meant add. Weigh meant equals. I crossed those out and gave them what sign or what operation or sign they translate for. That's all I did. Same thing on the bottom. All right? Tyler, what's my bottom equation going to be?
4G.
4G.
10A
worry, buddy. I had an older brother, so it's all good. All right, so 8g plus 4, so those are our equations that are going to go in here. Only reason why I didn't write them in there because I'm not as fancy as Mr. Hager. He can like move stuff around like a game wizard and like get everything lined up to where it has to be. I can't do that, so that's why I wrote them here. All I'm going to do is take these and write them in here. 8g plus 14a equals 15, and 4g plus 10a equals 9. So all I did was just line. Okay, next question has to be, are they lined up?
Yes.
KJ says they're lined up. I agree, right? We got the G's over the G's, all right? We got the A's over the A's. We got the numbers over the numbers. We got letters on left, numbers on right. We're good. Now we got to ask ourselves this question.
Bottom. Bottom.
Why bottom?
Because
You have to
4.
get the G out.
All right, good. I agree. Plus the numbers are smaller on the bottom. I like that. So let's go bottom.
Bottom's up.
Now,
So eliminate.
my friend Mr. Nermi,
Where's the free elimination?
you got some direction from your friends here. What, we're saying this bottom equation, right? What variable do you want to eliminate? G or A? A? That's a big number, man. 10's a huge number. I like G. All right, let's eliminate G. All right, let's eliminate G. In this box, I don't want to know the number. All right, but what do I have to put in this box? The number that I want to do what with? Number I want to multiply, that number I want to distribute. All right? So, 4. KJ, what were you going to say earlier? To eliminate, what were you going to say?
You have to double it and make it a negative.
Double it and make it a negative. Like Kayla knows that 4, all right, she knows if she multiplies it by something, it can become 8. And she said that if she multiplies 4 by 2, it can become 8.
-2.
But exactly, that's only going to give us the same number. That'll give us 8 and 8. That'll give us G and G. But what do we need? What's the key to eliminate? Different signs. All right, we need different signs. That's why we're making this a -2. Because when I multiply, Tyler, when I do -2 times +4, what do I get? -8, right? That's going to start off my new, I'm going to rewrite the top, 8g plus 14a equals 15. Now my bottom, Tyler just told me, -2 times 8, times 4 is -8g, all right? -2 times 10a, what do I get, guys? -2 times 10a. Who said it? Thank you. -20a. And last one, my good friend Mr. Shaw, -2 times +9. Let me ask you this, my friend. Is your answer going to be positive or negative? Do a -2 times +9. Nice. Good, I'll let you off the hook. 9 times 2 is what? 18. Perfect. Justin, in this problem, take a second and look. Don't just say 55. Take a second and look. What what variable are we eliminating again?
The G.
The G, right? So what can I do to it?
That would have been so far.
Cross them out, right? Now, Laura, what do I do next? Combine like terms, right? So I'm doing 14a, +14a, -20. If you couldn't, I'd be forever in debt.
I hear you say like low whispers.
-6a equals, what's 15 and -18? -3, right?
It was her turn.
Ryan.
Yeah.
Ryan.
Mr. Wrong.
Thanks, buddy. Can you tell me what I gotta do now?
Add 6.
No.
Very quiet today.
Spencer, how about your buddy over here? What are you gonna do here? By -6. -6. Right? Top and bottom are both negative. Huh? 1/2, right? Number one, it's going to be positive because the top's positive, top's negative, bottom's negative. And Isaiah said that can reduce to 1/2.
Isaiah, what does that mean? Because we're finding the cost of apple. What's 1/2? How much does that cost?
50 cents.
50 cents.
Exactly.
So I'm going to do, how can I represent 50 cents, guys? 0.50, not 50, that's 50 bucks. 0.50. Right, so an apple costs how much, guys? 50 cents. 50 cents. Now, do we want to substitute in the top or the bottom? Yeah, I would choose the bottom. Look at the number that's with A, 10, right? 10's you can count by 10s, 10, 20, 30, 40, 50, right? Pretty easy number. 14, we're getting ourselves in a whole issue that we want to be. So let's use 10, all right? So 4G plus what?
10
Times
What can I put?
0.5
And?
equals 18. No,
9.
9.
Was it negative, right? Okay. Good. So 4G plus what's 10 times 0.50? Is it
10.5.
your calculator, Mr. Hager?
It's like right there.
Right here, right?
Yep, that's it.
10, right? 10
Is that should be 5?
times, let's see, 0.50.
It's 5.
5, thanks guys. Jeez. Look at the big brain on you guys.
Good. Okay.
Look at the big brain on Brad. Now what?
Divide.
What now, man?
Subtract.
Subtract what? Subtract what? Subtract 5. Get that G by itself, right?
No.
Right, Ryan? Get that G by itself. Know what I'm saying? Get that G. Straight up G. 4G equals 4G equals what, guys?
Choose 1.
What's 1? But it's money though.
$1.
$1. Excellent.
$1.
Very, very good.
Potatoes.
Again, word problem. I'm telling you right now, on Friday, there will be a whole section on word problems. No, you're not going to fail. Again, just like last night, the last problem on the homework last night was a word problem. The last problem on the homework tonight is a word problem. The last problem on the homework tomorrow night will be a word problem.
Oh my God, Roy.
I promise you. Yeah, man. I'm Satan, man. I'm the Satan of math.
No. The only guy who comes up, I think that's a big.
The horse, man.
All right. So before I give you guys the last problem, what's the name of this method we're doing? Elimination. Now, I don't want you guys.
Guys, listen, please.
I don't want you guys to think that every single elimination problem now you have to multiply. You might have some like you did yesterday, okay, on the test, where you don't need to multiply. They're already lined up for you as opposites.
And guys, look at the board. The hint there, when you have one that you don't have to multiply, it's already set up, or you might have to rearrange to get it set up, there'll be no boxes. You'll know you don't have to multiply by anything because there'll be no boxes. What did I just say, Isaiah?
You don't have to multiply because there will be no boxes.
Good, thank you.
Wow.
All right, so your homework tonight will be a worksheet on 12.5, part 1.